we have this theorem, and it basically says you could state it as an if-then statement. You could say if it's a N-gon, then it has n minus 2 times 180 as the sum of its interior angles, but I'm just going to state it as a sentence, and we want to prove this statement here. We want to say, right, what does it say? It says the sum of the interior angles in an N-gon is n minus 2 times 180. Now, the first thing that we really want to understand is just that an N-gon is an n-sided polygon, right? So that's the whole thing, right? N-sided polygon. So, for example, right, the 3-gon is just your typical triangle. Right, this is a 3-gon. Right, 4-gon is your quadrilateral. So that's a 4-gon, more or less, if you forget about that piece. But yeah, 4-gon, 5-gon. One, two, three. Did I draw a 6-gon by accident? Okay, whatever. 6-gon. 1, 2, 3, 4, 5, 6. Yeah, 6-gon. Sorry, this is 6-gon. 4-gon, right? 4-gon. And then this here is your 3-gon, the triangle. Now, what you want to prove is that for any N-gon, for some N-gon, right, the sum of the interior angles. So in the triangle, right, the sum of the interior angles, let's call this angle A, B, C. We've already proven that the sum of the measures of these angles is 180. Now let's take a look at the 4-gon. Let's say I have A, angle B, angle C, and angle D. And what your task is you want to find out in this case what the measure of A plus the measure of B plus the measure of C. Up. Let's see. Can't see anything. The measure of C plus the measure of D, right? You want to find out what this is. But a way you could go about doing that is you could just fix a vertex and you could draw a line to every other vertex. So there's already a line from A to B. There's no line from A to C, and then there's a line from A to D. Now, what that does is that splits up angle A. And let's say that this is, I don't know, angle X, and then this is Y. We should see immediately that X plus Y is angle A. So in this sum here, instead of me writing measure of angle A, I'm just going to swap it out with the measure of X plus the measure of Y. And that's going to be my first thing. So I'm going to write measure of X plus measure of Y. And then I'm going to rewrite the rest. So this is for sure equality. Measure of angle B, measure of angle C, and then measure of angle D. Right? And you should see that there's equality because all I did was that instead of me writing measure of angle A, I just wrote it as the measure of angle X, whatever that is, plus the measure of angle Y. Now, if you rearrange this, and I'm going to rearrange this in a particular order, I'm going to write it measure of X plus measure of B plus measure of C, and then plus the rest, so measure of Y. And also, so I messed up because what else do I have to split up? So let's call this C also got divided. So let me take the time to rewrite C before. So measure of C. Instead of me writing measure of C, I could write, so that's measure of angle X plus measure of angle B at the top over there. And then instead of writing measure of angle C, I'll write plus the measure of angle U plus the measure of angle Z. and I replaced C with U plus Z. And now I just write plus measure of angle D. And we should see that these two sums are for sure equal, right? I have it that this measure of A is just measure of x plus measure of y, and measure of C is just measure of U plus measure of Z. And now if we look at this, it should be clear that from what we know that the sum of the interior angles of any triangle is 180. So measure of x plus measure of b plus measure of u, you see that this here is a triangle, right? This forms a triangle here, right? We know that then the interior angles is 180. So this is going to give me a 180 plus, and now wait, what did I forget here? Z, I got, oh, plus y. I forgot measure of angle y here. And this here, right, y plus z plus d, that's this triangle, which again has to be 180. So now I get two 180s, which is 360. Okay, and now we can do this again with a 5-gon. You can do it again with a 6-gon. What you should see though is that if I do this a little bit quicker now, so what you want to do is you want to fix a vertex. Don't move that vertex, and just draw a line to every other vertex. And that's just a way of sort of dividing your N-gon into triangles. You see, you have triangles here. You have exactly 4 triangles. Look, 1, 2, 3, 4. And what you'll begin to see if you did this again for a 5-gon, right? So let's see how many triangles. How many triangles were in? This is the 4-gon. So let's start. Make this chart. Okay, so this chart's gonna help you out. So let's say n number of triangles, and then let's say sum of interior angles. So let's see what we get here. N. When it's 3, right, how many triangles are there if I fix a vertex in the 3-gon? Well, there's 1 triangle, right? That's tricky. And the sum of the interior angles is just 1 times 180, right? And if you go over and you say 4, well, the 4-gon, I drew a 4-gon here. What was this? How many triangles are there? 1, 2. There's 2 triangles, right? And then what was the sum of the interior angles? 2 times 180, or 360. But I want to write it purposefully as 2 times 180. Then 5. Okay? The 5-gon, if you look here, right, let's draw an actual 5-gon. So I'll draw the pentagon. So 1, 2, 3, 4, 5. Okay, I did a good job this time. And now let's see. So if I repeat that procedure, right, I fix some vertex and then I draw a line to every other vertex. How many triangles do I have? I've got 1, 2, 3. So there's 3 triangles. And you could run through this process again here, right? Let's say that this is angle A that I split up into, let's say, these 3 angles, X, Y, Z. B, C, let's say, got split up into, I don't know, M and N. And then let's say this angle got split up into P and Q. This is D, and then E, right? What am I looking for? I'm looking for the sum of the interior angles. Let's say the interior angles are A, B, C, D, and E. Then I'm looking for measure of A plus measure of B plus measure of C plus measure of D, it looks like a P, D plus measure of E. But that's the same thing as the measure of X plus the measure of Y plus the measure of Z, because that's just the measure of A, plus the measure of B, plus the measure of N, plus the measure of M, because that's just the measure of C, plus the measure of P, plus the measure of Q, because that's just the measure of D, plus the measure of E. And then you should see that E plus X plus Q is 180, y plus m plus p is 180, z plus b plus n is 180, and that's three 180s, right? So it would be three 180s. And you could run through a similar argument for the 6-gon, but you should just sort of convince yourself, right? There's four triangles, and it's just going to be 4 times 180. And then you want to now generalize, right? You want to start to get a general picture. If you need more evidence, you could draw a 7-gon. You should see how many triangles. There's going to be 5. And that you could then just see that it's going to be 5 times 180 for the sum of the interior angles. But you want to generalize. Now, what does that mean to generalize? You want to go down to some n. I don't know how far n is down, or could be any number n, right? How many triangles are there? Well, how many triangles were there when n was 3? There was 1. How many triangles when n was 4? There was 2. How many triangles? So forth, so forth. What's the relationship between these two columns? How do I go from n to the number of triangles? Well, just minus 2. So n is the number of sides. If I want to find out how many triangles are in the N-gon, I just do n minus 2. Now, each one of those triangles contributes 180 degrees. So what's the sum of the interior angles in an N-gon? N minus 2 times 180. And that's the theorem. You've proven the theorem after it is that you've convinced yourself that, first of all, there's n minus 2 triangles in the N-gon, and that each triangle contributes 180 degrees to the sum of the interior angles.